Hi, everyone, and welcome to the second week of our prep course. My name is Rahul, and I'm your instructor for this amazing full stack web development bootcamp. Before we proceed ahead with a new topic, let's quickly recap what we did last week so it is easier for us to follow what we are going to do this week. Because every topic that we are covering would be getting connected very soon, and you would be seeing how these all topics are working together, enabling us to access websites, how we are sending some data, how we are receiving some data. So very briefly, we will go through all the major points, important characteristics, and examples. Let me switch to my whiteboard so that it is easier for us to understand. Perfect. So just give me a yes if you're able to see the whiteboard. Perfect. So weekly recap, this was our first week from 5th of December till 8th of December. We covered some amazing topics. Let's go through them one by one. The first topic that we covered was a network. What is a network? A network is simple. You have to remember just three or four conditions. Number one, group of devices. Number two, they must be connected together. Number three, they are able to share or receive information. And this only happens when they are following standard set of rules, when they are using standard protocols. So very shortly, I've written every point for you. So it's just group of devices connected together, sharing resources using standard protocol. Just remember these definitions and you will be able to print a mental picture for yourself how a network is being formed. Now, moving further, the second topic that we did were network components. Based on these conditions, we can very well judge that there would be four network components. First network component was based on the devices. Second was based on the connectivity. Third was based on sharing the information using standard protocols. So let's see. First device is called nodes or hosts. Our first device was called nodes or host. This is everything that you use to interact with web. It could be your computer, it could be your mobile phone, it could be your printer. Your printer is connected to network. You're able to send or receive prints, your fax machines, your refrigerators are host. Today, you can check the temperature, you can reduce the temperature, your air conditioners, your GPS systems, everything that is connected to web, which you can control through your device or you can receive a data is called a host. So the second point was medium, how this particular device is connected to internet. There could be various sources, yeah, like electrical cables, fiber optics, or radio waves. Radio waves we are generally using with mobile phones. Moving ahead, it then was interface. Interface is the connection between this host and medium, like your integrated adapter. The one that you use on your laptop, there is a separate port wherein you enter your LAN cable. That particular port is a connection between your device is the laptop, your media is the LAN cable. That particular port which joins both of them is called the interface. And last, protocol, set of rules. These are standardized rules. We cannot change them, we cannot alter them. So this was the second major topic. Moving on to the third major topic was internet. What is internet? It is a global network of many small networks. When small networks, suppose your home network, your office network, when all of these networks are connected together globally through various media, connecting media, it could be wireless, electronic, optics, that is called internet. So in short, we can say global network of many small networks, and they must be interconnected through some media. So just remember these four conditions: devices, how they are connected, are they able to share information, and are they under same protocol, same rules. We would be covering some major protocols in this today's lecture in great detail. So moving ahead, our next topic was submarine cables. Submarine cables are the media, are the connecting media that transmits internet globally. So these are large cables which are laid across the ocean floors, the seabeds, and they cater 99% of internet worldwide. So this is like the connected media. the network media for the global internet. These are laid along seabeds. We saw a particular image of a globe, of a map, wherein we saw many cables going through continents and across the oceans. So that is submarine cables. Next was the internet services. Internet services are a pathway. These are the intermediates between the service that you're enjoying and how that service reaches your computer device. For instance, you want to send an email. How you are able to send an email from your device to some other device, the intermediate between them, the application, the email application is your internet service. That runs because of some separate protocols like simple mail transfer protocol and so on. So this is just understand this is a pathway between internet servers and your computer device. So for instance, this is a server, if we name it as S, and this is your computer, and you want to receive some data, the applications or the way through which you would do it are called internet services. So there were many services like communication services. So like you're able to chat with a friend, you're able to talk with a friend online. That is happening through communication services. There are file transfer services, file transfer protocols through which online you can share files. If this is your file, this is your file, you can share online very securely. Those come under internet services. So certain internet services types I've also discussed over here. First, just remember this is a pathway between, the middle pathway between internet and your computer devices. Now, what are different types of internet services? So as we said, communication service is for your email, video conferencing, everything. So all kind of communication that is happening over internet comes under this kind of service. Your information retrieval service, you go on a web browser, you search something, and you get a particular answers to your questions that happens through the rules laid under information retrieval service. The next comes file transfer protocol, as we discussed. If you want to send files across internet very securely, that is called file transfer protocol. And lastly, we discussed World Wide Web in great detail. It is a network of web pages, network of websites, network of servers. Reason it is called web, because web pages are connected through hyperlinks. What is a hyperlink? It is a connection between one web page to the other. So this is general internet service types. So these were discussed in the previous week. Next, coming ahead are few other topics which we discussed. First one, what is a web page? Web page is a document written in HTML. So simple image we saw, like this is your web page, and here is your heading. Here is one image. Here is some video, I say, and here is footer. This is your HTML document. These are HTML tags, and we would be starting once we move to the core technologies. So this is your web page. Web page is what? HTML document. Just remember this. An HTML document is called a web page. It's a document written in HTML. A simple definition for web page is document written in HTML. HTML is a markup language which tells what would be there on my web page and where it would be there. What would be there? Like I want a heading, I want a recording, I want something else. So that things are written under HTML. Second, what is a website? Collection of many web pages together is a website. For instance, suppose we have this website which has few hyperlinks over here. This says home, this says about, this says contact us, and this says FAQs. So all these links would lead to a particular web page. So collection of web pages is called a website. So there must be some content over here, but when you click over here, you would go to home. When you click over here, you would go to about. When you click over there, you would go to contact and so on. So all these web pages together is called a website. So next, we understood what is a web server. So collection of web pages. So before we move to web server, collection of web pages, which is connected through hyperlinks is called a website. So this is a hyperlink. This is a hyperlink. This is a hyperlink. So we started that you can go from one hyperlink to other in the same web page, in a same website. Similarly, you can go from one web page to another web page in a different website. Next topic was web server. So these systems, these are special computers which make a website available to everyone on the internet. So if this is our internet, if we assume this to be our internet, World Wide Web, and now the website is available for everyone over here with the help of a web server. So today we would be discussing web servers in detail, how a web server looks, uh, how they are stored in large companies, and so much more. Next, simple was web browser. Web browser is an application through which you access your web page. So if you want to access a particular web page, supposedly you want to go to, let's say Amazon.com, you use a web browser. It is an application software wherein you enter the website address and you get the website or web page right in front of your screens. Similarly, the next topic were hyperlinks. So hyperlinks, as we discussed, they are connection between web pages from one web page to the other. Suppose this is a web page and I have a submit button over here. Now this is a form. This is a forms, a login form. If I click submit, I'm getting another web page that your account has been registered. So this is kind of a hyperlink, a button that is moving me, taking me to another page, or there must be some other hyperlinks like contact me, FAQs, as we discussed. So we can give functionality to anything. A hyperlink can be attached to anything. It can be attached to a text. It can be attached to a button. It can be attached to an image. When we click an image, we would be directed to a particular website. For instance, let me show you a beautiful example. Let me open Google Chrome for you. Okay. For instance, if I write computers over here, and now if I click on images, and now this is, but every image is a hyperlink. If I click a particular computer over here, I'm directed to its website. Just check this out. I click over here, I'm getting some information. Once I click this image, I'm directed to a new website. So this image has been set up as a hyperlink. If I click this image and if I click over here, I'm directed to this website. So this is a hyperlink. These are called external hyperlinks. The hyperlink from Google's URL is directing me to some other URL. This is Britannica URL. So if I click this particular hyperlink, now just see my URL, my domain name doesn't change. However, I move to some other web page. This is internal linking. When you move from one web page to another in same website, I'm in same website, Britannica website. If I click on computing basics, I'm still in Britannica.com. So this is internal hyperlinking. And over here, this is external hyperlinking. If I click over here, I can see Microsoft logo. When I click over here, I'm directed to Microsoft website. So these are this is the definition of hyperlinks. So let's get back to our topics. So this was the hyperlinks. The last topic that we did was search engines. So this was a pretty big topic. So search engines are basically the, I would say, an application software's ability. So our browser is an application software. Search engine is an ability to provide accurate results with which are relevant to the user. So the some basic points we need to remember. It constantly scans web pages in advance using the spider crawling method. We saw there is a spider program which crawls through web page from one hyperlink to the other till it finds the required information. Then there is search index. As per the crawling method, it keeps on recording which word, how many times it appeared, and so on. We talked about the ranking algorithm, which checks certain parameters while checking the query and the web page. Like, is the title of the web page matching with the query? Is the sequence of the words matching with the sequence of words present on the web page? Are there any similar keywords? Accordingly, the web pages are ranked. Similarly, we studied the page rank method. This was developed by Google, wherein the idea is how many other websites have recommended the particular web page. And accordingly, if many websites have recommended a particular web page, then that web page is shown on top of list. So this is a very brief overview what we did in last section in last week. So now let's move on to the topics that we would be covering today. So today The basic topics that we would be revolving around are client server architecture, request response cycle, and how web works. So let's see the topics that we would be doing. The first topic is what is a web browser and its components. We all are pretty familiar with web browser. We all are pretty familiar with components itself. So it would be a very short lecture regarding web browser and components. The main idea behind going through this topic is to understand the interface and how a particular web browser is useful for us as developers. The second topic, what is client, what is server, what is their architecture called? The third major topic is request response cycle. These two topics are very important. They tell us how a request, how a particular URL address moves out and gives us the required page that we want with all the information, all your HTML, CSS, JavaScript. So this is very important. And combination of everything that we would be studying comes under this, how the entire process works, how entire terminologies work. So let's start with today's session. What is a web browser? Okay, so let's do one thing. I'll just go through very some basic points, and then we would see actually by doing some actions on a web browser how it is responding. So let's go through some brief definitions. So according to me, a web browser is like, it can take you anywhere on the internet. It can let you see text, images, videos from anywhere in the world. So it's like a gateway. So if I have to define it, it's like a gateway. It's a gateway to the World Wide Web. If you want to access something, some information, you need some source to enter that world. And that source to enter that way to enter particular web site structure is your web browser. So let's see an example. So it's like an interface between us and information available on the web. So it's just like a intermediate gateway. So remember this. So next, how it works, it works under information retrieval services. So what is information retrieval services? It is one of the internet services that we studied. So how it works, whenever we go to the browser, we search something, we are consuming information in one way or the other. That information can be in form of web pages, it can be in form of texts, images. So those information that we are consuming is possible only through information retrieval services. So that's why it's called a service. It's a part of information retrieval service. So these are some very popular browsers that everyone is using. Number one is Google Chrome, Firefox, Internet Explorer, Safari, Opera. So 5 major browsers, and the one that we would be using for this web development bootcamp is Google Chrome. There are certain reasons that why we are using this Google Chrome. The main reason is Google Chrome has many inbuilt features and capabilities. These inbuilt features and capabilities make writing code, make debugging code very easy for us. The best part is we can test Chrome developer tools on any website for our ease. And we would be studying Chrome developer tools through our entire journey of creating beautiful websites, because these tools only help us to see how actually our websites is looking before handling it to the backend team, or before giving it to the client as well. So let's quickly go to the Chrome developer tools and see how it works. So let me open the browser once again. Okay. So the best way to do is just click on inspect, and a particular console would open, a particular developer tool would open. There are many elements over here, like your styles, computed, layout, event listeners. So the one that we would be testing right now, we would not go into very deep details. I'll just show you how it works. So this is where HTML, CSS is written. This is where HTML, CSS you can find. And when I hover over it, you can see that sections are getting highlighted over here. So how we can use it? Suppose you want to target this particular logo. What you can do is just click over here, this particular arrow and a box. And when you go to this Google logo and you click over it, your particular section in web developer tool gets highlighted. And if you see it, it shows that this is an image tag. IMG tag is for image. There are certain attributes written, and this is the Google logo. Similarly, if I go down and I see, I can hover over this search bar. So I can make changes over here. These changes are temporary. For instance, I can write something else over here. So this is how we use. So this console, this is for printing things. Here you can directly write JavaScript as well. For instance, if I write 2 plus 2, it will give me an answer, 4. So if I write, it's a very simple JavaScript command I'm writing over here. But do not worry about it. We would be starting to print something over here. We can simply write like console.log, and I write, let's say John. And a simple message would be printed. This command is for printing something over here. So we would be covering all this in the JavaScript section, but the motive over here is to tell you how Chrome developer tools are so helpful. So not only on Google, if I write amazon.com and if I open this website, just see. Right now, if I want to click on this particular image, what I can do is I can just go to elements, go over here, and once I click this, I'm getting directed to this particular image, shop gift guides. I can go to other images as well. Like this particular image, you can see keyboards, which one I clicked. I can click, supposedly I click video games over here. It can give me the video games. So I can make some changes over here and see them real time. Before deploying it, before giving it to the client, I can see how it looks. Some other features, if you click this one, it gives you the responsive design, that how it would look on your iPhone, a particular website, how it would look on your tablets, your iPad Air, how it would look. Your resolution would change. So you can make it responsive using Chrome developer tools. So this is how we would be working through our entire journey, making websites, debugging them, and seeing how, and we would see how we can make sure everything is in right place. So this was a very brief thing about Chrome developer tools. So this is one of the reason that we use Chrome. So moving ahead, let's understand the interface of the browser. So we have been using it every time, every day we are using it. The reason behind discussing the components and the interface of anything is that whenever you are working in a team, every team member or your seniors are discussing in technical terms. And sometimes we do not know what those technical terms are, and having a communication with your seniors becomes very difficult. So when you're familiar with the technical terms, when you're familiar with how something is working under the hood, then building that communication and explaining your stuff is very easy to someone who has already worked for many years in this industry, because they are very used to some technical words rather than normal words. So let's see a basic interface of our browser that we would be using, that is Google Chrome. So this is a simple Google web page. And I have mentioned all the parts of the Google browser interface. So let's go through them one by one. So number one, this is search engine. This helps us find the right page whenever we enter our query over here. Where do we enter a query? In the search area. This is the query region. Where do we enter? Over here. And who helps us? The search engine helps us find the right answer. This is the address bar. Here the website address is found. Your website address, google.com. This is the address bar. So we would be studying different parts of your URL as well. So, but that is for the later part of sections of our lectures. So to just remember, the website is put in the address bar. What is a new tab area? Whenever you open some multiple tabs, this is one tab. If you open another tab, second tab would open over here. So this is to, when you click, another new tab would open. And forward back buttons are to switch between tabs. Reload is whenever you're not getting the request, the response to your request properly, you can reload and check if your server is working fine, if your internet connection is working fine or not. So this is bookmarks tab. If you want to save this page and you want to access it later without worrying about that, you have to go through entire process of searching which page was that, you can save it or edit it under your bookmarks tab. And these are certain tools for settings, like how your what should be the display mode. Should it be light theme? Should it be dark theme? Or do you want to share location? Do you want to share your audios and visuals and other tools? The settings bar. This is where the settings for the Chrome we can adjust. So this is a basic interface. So major we would be dealing is with the address bars, with the search bars, with your search engines, and these are the major regions that we would be dealing with. So now we have studied some very basic structure of how everything is working. What is network? What is your one user? What is the other user? What is a host? The network devices are called host. Let's connect everything together to see how actually what we have studied so far is working. So suppose we have a user. Suppose there is a user who wants to visit a website, for instance, wikipedia.com. So he goes to wikipedia.com. Now, how would he go to wikipedia.com? He opens his browser, enters that website into the address, into the search bar. Remember, this is search bar. He can enter the website into the search bar. And now here Chrome is the browser. Here browser is our Chrome, but the search engine is Google. So our search engine is Google over here. So remember. So there are, now what happens? We have done our part at our end. Now, how would we go to the wikipedia.com? So now there are company computers, many computers that are keeping the information regarding the requested website. And in order to get that information, we need to get in touch with those computers. So these computers are at an unknown location. These are owned by the company which we are requesting the website of. So like it could be owned by Wikipedia, or it could be some other company who is providing services to Wikipedia for keeping their information. So let's assume Wikipedia has its own computers, which keeps the data of their website. And I want to access it. In order to get that, I need to build a connection. This connection is built via internet. So let's see. So this is the connection between me and those computers which hold the data, right? So now the internet is working like a pipe. This is like a pipe between me and the other one. So this is one host. We remember two devices. So these are two devices connected together. This is the connection being made, and they are ready to share information. So this forms a network, and in a network, the devices are called host. So now the pipe is the connection between the host and your data source. So internet is like a pipe connecting host and data and to the data source. This is the data source. This is the data source which is holding the information. So these data sources here, we are requesting Wikipedia's data. So the data source are Wikipedia owned computers at unknown location. So as we discussed, these Wikipedia owned computers, and the location is not known. There are several reasons behind it, for security reasons as well, so that nobody can hack their data. Nobody can get access to physical devices which are storing many, like huge information regarding users, their accounts, their passwords, and so much more. So if we see this setup, just see this setup. This is one device, this is second device, they have been connected and they are sharing information, right? So now this makes it a network. This is one network. The devices under the network are called hosts. Our user, this is our user. Our user is called the local host. What does local mean? Something you are interacting personally. The user is interacting through computer personally. This one. So this is called local host. And the one which we do not know where though that particular host is located, that is remote host. So this is what different hosts are called. Any doubts so far before we proceed ahead? Just give me a yes, no in the chat. We're just trying to connect things that we have studied so far, that how a network is created in actual daily life. Perfect. So moving ahead, this internet, now we have, we remember that there are different network components. One was your devices. This is your device. This is your device. Second was your network media. Now this pipe, the type of pipe that we are using would be serving as your network media. For instance, if you're using electrical cables, then that is a network media. If you're using fiber optics, that is a network media. Internet is flowing through that particular type. So the type of pipeline becomes a network media. So now comes what is client and what is server. To understand this, the local host is asking the question, is requesting information, and a remote host is providing with the web page, I would say. Our user is asking, so it is called the service requester. So let's see the definition. The host that is requesting some information or data or any service are called service requester or client. So this becomes our client. This becomes our client. And now the systems that provide those services, that provide that information, that provide the data are called service providers, and those are called servers. So the systems that are providing the information or data or service are called service providers. So here this becomes our server. What is a server? The service provider, the data provider, the information center. So this becomes our server. So this is the overall setup of how a particular client requests the information and gets the required information fulfilled. So this is a very brief introduction. Under the hood, many things are happening over here. Through the pipeline, many things are happening. Many protocols are being tested. Many servers one has to go through. How a particular website address is understood by the server, that process is happening. So these we would be studying now. This is a general overview that a device connects through internet to some information source. One device is requesting the data, the other device is responding with the information. The device requesting the data is called client. The device providing the information is called server. So let's understand this client server analogy with a very beautiful example. So suppose you are in a restaurant. So you're in a restaurant and you're sitting over there, you're browsing through the food menu. You're just deciding which item to order. So now that you've decided, you want to order multiple items out of it. So this is you sitting at a restaurant and you have decided that what you will order, and you've decided that you would order 3 to 4 items. So you call the waiter. So this is the waiter. You call the waiter. Okay, take my order. So waiter comes, he notes down your order, and now he has made the list of 4 different dishes. So now the waiter goes to the kitchen and reach out to the specific chefs who have specialized in making different cuisines as per the category of items requested. For instance, this particular chef is good at making non-vegetarian cuisine. This particular chef is good at making vegetarian dishes. This particular chef is good at making your salads, and this particular chef is good at making soups or beverages. So the waiter goes to particular chef and gives them the respective order that the user, that the we can call it uh, customer. Sorry, we can call the customer has ordered these 4 dishes, and it gives the waiter gives it to different chefs. Now, what happens over here is the customer that is requesting the food. This customer becomes the client. This is the requester. He or she is requesting the waiter to get me this food. Now, waiter becomes a medium. Waiter becomes a medium between this and this. It goes from client to the chefs. The chefs becomes the server. Why chefs are server? They are the information source. They hold the data of a particular recipe. They know how to make a particular recipe. So these are 4 different servers over here. One is for non-vegetarian recipes, one is for vegetarian, one is for your salads, and one is for your drinks. So now when the dishes are prepared, the waiter takes the dish from respective server and brings it back to the client. So if the non-vegetarian dishes have been prepared, waiter brings that first. If your salads have been prepared, waiter brings that one first. If your vegetarian dishes then prepared, waiter brings that one. So every time a particular dish is prepared, waiter brings that to the client. So what happens over here? So main point that we need to understand over here is that one client, this is one client, I'm considering this as one client, is getting in touch with multiple servers through network media, through internet. So major point that we need to remember is that this is your client medium server. What is your client medium server? And that one client can communicate with multiple servers. This is very important. That suppose you have a PC at your place and you want to access emails, you want to transfer files, and you want to watch videos. Now there can be multiple servers put together, and same client can access those servers at the same time. So this is what one client can communicate with multiple servers. This is one scenario. The second scenario comes is suppose the restaurant is full. There are multiple clients. Each of them calls their waiter. These are your clients. And each of them calls the waiter and orders the same dish. So let's mark the clients. So these are your clients. Each of them calls their waiter and orders the same dish. Suppose they order non-veg food, non-vegetarian food. So now each of these would go to the same server. This is the server. So each of these go to the same server, just over here. One server they're accessing. Now, once a particular request for a particular client is fulfilled, the waiter comes back with that. The waiter goes and delivers that. And similarly, the waiter goes and delivers that. Here, waiter is still the media. The requester is the client, and the server, the one who holds the information to make a particular product ready, is called the server. So the major point to remember over here is that multiple clients can access each server, or we can say one server can be accessed by multiple clients. So how it works, suppose this is your server and this is your email server. And there are 5 PCs who are accessing, or say 3 PCs accessing your email server at once. Sorry, guys. Yeah. So what's happening over here is like, if you consider Gmail server, billions of users, millions of users are using their server at once. So many computers are connecting to their server just to get access and check their emails at same time. So that is what we call each server can be accessed through multiple clients. So this is a very generic example that we see in our daily lives, what chefs are, what we are in a restaurant scenario, what a waiter is. So whenever you feel confused at how client and server is communicating, just remember the properties. A client always requests, a server always responds. The medium is the interaction between them. So there are many things happening in between this, apart from just internet, that we would be studying under how web works. So let's move ahead and see and understand what technically client and server is. So this was very generic definition. So what client actually means in web world? So we would understand by asking some important questions and answering them. So the first question that I would like to answer is that how to identify if something is client or not. The major question comes is, okay, we understood the definition, right? That client always requests, and client is the asker. Client wants some product from some other computer. But how do we identify a particular client, that this particular device or this particular software is my client? So a client is anything. A client can be anything. Just pay attention. A client can be anything that establishes a connection with data source. There is some data source over here. All my data is lying over here. If my client is able to establish a connection with that, we studied how connection is established by a network principle. Two devices connected together able to share information. If a particular device or any software is able to do that, that is called a client. And the other one should always be the data source. If one of the device is able to connect with data source by fulfilling the conditions of network, then that is called client. So it can be any device which is able to share or receive information. So let's see a beautiful diagram of it. Just a simple, just don't assume it to be a computer. This could be anything that establishes a connection. This is one loop and this is the other loop. And this is the connection being shown. If anything that is able to develop a connection with the data source, this is the data source, then that thing is called client. Now, question comes, which devices could be client? Usually when we think of a client or device, only computer comes to our mind. But today, any network compatible device, pay attention to this word, any network compatible device, any device which is able to establish a connection by fulfilling network rules can be said to be a client. This could be a laptop. This could be your smartphone, watches, camera. Today, this could be your smart bulbs as well. This could be GPS in your car. This could be a refrigerators, cameras, anything. So let's see a few examples. So main thing that we need to remember is network compatible device. You need to make sure that your device is able to establish a network. With whom? With the data source. Now, this could be anything, computer, laptop, smartphone, or even your lights, appliances, like your refrigerators, you can control temperature, like camera, you can click with your smartphones today. You can print without attaching wire through radio waves only. So all these devices that you see, so this is the server over here. This is the data source. So through the network, all the devices are getting connected to this. So this is what a client is, anything that can establish a connection with the data source. So now the next question comes. So these are all tangible devices. We can touch them. We can touch a fridge. We can touch a microwave oven. We can experience a car. We can touch smartwatches. So these are all tangible devices. So can there be any client other than these devices? So the answer to this question depends on from which point of view we are looking at. The first viewpoint can be if we are visiting a website, a simple website, then the device that we are using to visit that website, these devices, even smartwatches or any PC as well, these devices are your client. So this is what we have studied so far, the devices. The second viewpoint comes that if you're talking about a software, if a software, suppose I mark it as a software, if a software is able to build a connection with the data source and is able to receive or send information, then that software can be a client. The most used software as a client is web browser. So web browser builds a connection with the data source. We use web browser and access the web page. So web page is the response. Just remember, client, this is the client. This is your sharing information. This is data source. And once this happens, we receive a web page in general. So this client over here could be your browser. The browser establishes a connection with the data source and displays us the web page. So the main reason behind discussing this is that even softwares can be your client. So whenever you hear that web browser is the client, don't get confused. It is possible, and web browsers are the client. So this was regarding the client, and the major thing that we need to remember is it runs locally on your computer. It runs right in front of you. You can interact with it. So in short, if we have to summarize what a particular client is, I would say it could be anything. It could be your browser. It could be your mobile applications. It could be your devices. Anything that you're using to interact via internet. So just see a basic definition. It's just to summarize. So anything, remember, it could be anything, your browser, apps, or devices that you're using to interact with the internet. So it could be anything, your tangible devices, then it could be your browsers, it could be your email servers, it could be your anything that you're interacting with. So this could be your client. So this was what a client technically is. So in next time, whenever you are working on your laptop, just see, are you using browser as your client? Are you using your device as a client? Are you using some mobile application as a client? It could be web application as well. So this was about the clients. Next, let's move ahead what exactly server is. And coming on to server, the major questions that we are going to tackle are, what are some important features of server? How does a normal server look like? What are different components of server? How do companies, large companies, keep their servers? So let's discuss these few questions regarding a server. The first question comes, what are some important features of server? So far, we have been calling a server as data source, right? So we have been calling this system as data source. So from this first thing that comes to our mind, they hold the data. They are able to provide that data. So the main feature is the ability to store, ability to retrieve, and ability to transmit data to client. So three major things that we always need to remember. Store, we can store data in a server. We can retrieve data. And we can transmit data to some other data source as well. This data source can be connected to some other data source. So this is possible. So we would be seeing that. So now this is one of the features. These features are on the basis of working functionality. On the basis of how they are constructed. So they are like supercomputers. They have immense technical capabilities. They are highly powered, and they act as central sources of data for billions of users. So let's see a short bullet points regarding that. They are highly powered, very powerful. Like their configuration is up to the notch, the best configuration you can get in any computer or any software. They are centrally located. Just see, centrally located, providing information to various clients. So this shows us an example of many clients to one server. Like the one we saw in the restaurant example, one server interacting with many clients. So for example, email server. At the same time, thousands of computers are trying to access their emails. They're highly powerful that they're able to handle those clients. They're able to provide on with a blink of eye that how everyone is able to access, send, delete their emails, and so much more. So this was one of the basic features. So now comes how a normal data server look like. Normally, bunch of servers, single servers. A single server is simply like a box of pizza, I would say. The shape of a single server is like a box of pizzas with many holes to attach wires, many lights, and many switches. So normally, these box-like structures are stacked above each other, one above each other, and so on. So I'll show you a very beautiful image that these structures are called a rack. So this is what a normal server structure looks like. So all these, just see over here, these are individual servers. This could be of same type, this could be of different type. They could be catering same user request. They could be catering different types of user requests. For instance, this could be your email. This could be your for videos. This could be your file transfer and so much more. And this structure that you see over here, this is called a rack. This is how normally servers are kept. And what makes them different from normal computers? These normal servers do not have like your monitors, keyboards, or mouse. They lack graphic and audio cards generally. So just go through the picture and you'll understand they are very different from normal computers. They are targeted to perform specific functions with high precision and high speeds. So this enables one server rack to fulfill different requirements even of same user. So this is like if this is for email, this is for file transfer, this is for videos, and one particular client is accessing it, then this could be many servers tackling one client. This is one server which caters to many clients. These could be many servers which are catering to different needs of single user. So we can see practical examples of how it is happening. Next comes what are different components of server. Now, server provides two main functionalities. The first functionality is quickly processing data. They need to process data very fast. So for instance, you go to YouTube and you click a video, it doesn't take 10 or 15 minutes for the video to reach you. Hardly 5 seconds. If your internet is way fast, then within a blink of eye, your video would run. So how is this possible? The servers are having high speed RAMs, random access memories, which increase the capacity to process the request. The high speed RAMs provide low latency. The lag is very less and the data transmitted is at high speeds. So our laptops usually have 1 or 2 RAMs, but a single server can have number of RAMs. Let's see a simple image. So these are the RAMs. This is a single server. See how many RAMs are attached to one single server. That shows how much technically advanced a single server is. Moving on to the second main functionality. The second main functionality is to store and provide data faster. In order to achieve that, every server has multiple hard drives, and these hard drives are designed to operate at higher speeds. They are designed to store more data. They have high processing power, extremely high processing power, and they are extremely better performant than regular desktop. Let's see how a general hard drive looks like in a single server. So this is one single hard drive. See how many hard drives have been attached to one structure, one single server structure, how many hard drives have been attached. So this is one single hard drive, which in itself is very advanced, very high performant. The lag is very low, storage capacities are very high. Now, this is what a general server and its components are. Next comes how big data centers, how large companies are storing their servers, what their servers and their server racks look like. So if we consider like Facebook, Amazon, Google, they have huge rooms, huge buildings which are equivalent to hold like 2 commercial aircrafts, I would say. Each building is equipped with so many servers and so many racks. These rooms are called data centers. So I have an image that is from one of the server rooms of Google data centers. It is just one of the server rooms. So just see, these are individual server racks. This is one rack. This is second rack. This is third rack. So many servers are over here. And this is just a glimpse of it. There are many rooms like this, and each room is big enough to hold almost 2 commercial aircrafts. So this is what a general server room of big companies look like. So now we've discussed what a general server is, what a client is. Now, as per the client request, these servers were categorized into different subcategories. So few of them I've discussed that we use on daily basis. So there are some important categories of server which cater to specific request. Let's discuss few of them. Some common types of server. Number one is your web server. All the web pages you visit are served by these servers. These servers can help you show variety of information. They can help you show image. They can help you show videos. They can help you show text. In order for these servers to receive the request sent by the client, they must follow a specific protocol. That protocol is HTTP protocol. This is very important protocol for us as developers, because in backend, when you would be working, The HTTP protocol is very important while pulling out the request, pulling out the response, checking what response we have got, what is the status code, and so much more. So we would be focusing so much more on this part. And this server helps you show variety of information. Anything you see on web page has to go through web servers. The second one is your email servers. As we discussed, it makes life easy for us when we are sending emails, when we are receiving emails. So the request under email servers must follow a separate protocol, that is SMTP, your simple mail transfer protocol. So for sending, receiving emails, they follow SMTP. So different protocols were designed for a particular server. For instance, if this is my client and I have sent an HTTP request, and here I have email server. Now, when this request comes, this server will directly reject it because it is not following the protocol that this server has been designed for. Similarly, so if I have SMTP and over here I have web server, and this request comes, the web server would reject it because we're targeting the wrong server with some other protocol. If this request comes, this gets accepted because HTTP is a request that web server allows to pass. So always remember if you're using the right protocol and are you targeting the right server when sending a request. The next is your database server. So in order to access user data, in order to retrieve data, for instance, if we are using some database like MongoDB, and then we want to access some information stored under it, we have to build a connection with its database server. So for accessing and retrieving data, very simple. Moving ahead, FTP server, we've already discussed. FTP servers are for your file transfer protocols. It tells us to send or receive files over internet securely. Then last one is your video streaming server. This allows you, this streaming server usually used by YouTube and streaming platforms, all your OTT platforms like Disney platform or Amazon Prime. They use it to stream videos, to go on, live on their platforms, to have live sessions, video conferences, and so much more. This happens through your streaming server. So why these servers were divided? These were divided because whenever a client sends a request, the request in itself is very huge. When it has to come back, it is very huge through the data source. So what data source does is it breaks the request into small parts and sends through particular server through particular route. So that's why these servers were divided. If your web server, if your particular web page has some streaming content, that streaming content might be coming through streaming server if that company has used that particular server, or else web server is equipped enough to handle itself videos and text and images. So one of the reasons big companies are dividing their server so that the workload gets divided and each server takes very minimal time to fulfill the request. So this was what a particular server is. The next example is the technical example of how one client is getting in touch with the server. We've already discussed this. This one single client connecting with multiple servers. And if we move ahead, one particular server connecting with multiple clients. So this is one scenario. Second scenario is one client, multiple servers. So we've already discussed how it works. So now I think we have studied way too much details. Let's take a very short 5 minutes break and see a video, a very nice video that how Google is managing our data, what it does behind the scenes, how its data centers look like. So I'm just starting the video. Do let me know if you're able to hear the sound. So I have a question, like what about Zoom? Can you please just explain a little bit about it? Like what about Zoom? Like Zoom is a video conferencing platform, right? And that Zoom can be through streaming platform. It can be through web server as well. If that was your question. So live stream usually happens through streaming platforms, through streaming servers. So all the OTT platforms, all your YouTubes, If they have to go live, they use the streaming servers because those streaming servers do not have any other functionality. They're only designed to handle that aspect, and they're very good at it. Those servers are very good at handling only that aspect. They do not know any other thing. If any other request comes to them, they redirect that request to some other servers which is capable to handle that request. So let's move ahead, and I'll quickly share my sound, and I'll just play for a second and let me know if you are able to hear the sound.
Google builds and maintains one
is
of
the
the world's
sound
foremost
audible?
networks. Google builds and maintains one.
Perfect. I'll quickly restart the video. It's a very short video. So okay, let's start.
Google builds and maintains one of the world's foremost networks of data centers. Their design and engineering approaches have created a large and highly scalable data center network. Over the next few minutes, we're going to get an exclusive inside look at how Google works to secure and protect the data that is stored in their data centers. Inside of a Google data center, there are thousands upon thousands of machines carrying out the business of Google and its customers. The machines are custom built by Google to their own specifications. Google builds thousands of servers every year, but all of them are built exclusively to run in these data centers. Only the necessary operating system services and hardware are installed. This helps provide a computing environment that is much less prone to vulnerabilities. Access to Google data centers is tightly controlled. It's in Google's policy not to allow public tours or site visits. Security personnel are on duty 24 hours a day, 7 days a week. Google data centers are watched by a comprehensive set of video monitoring cameras. Once granted access to the facility, authorized personnel must check in at a reception area. Google takes great measures to protect its customers' data, and the security and protection of that data is paramount. Google's customer data is stored in multiple locations to help ensure reliability. The files that store the data are given random file names and are not stored in clear text, so they're not humanly readable. For each hard drive that is received in one of our data centers, Google rigorously tracks its location and status. When a hard drive fails or begins to exhibit performance problems, it's brought to this area, where it's reformatted and retested. If the hard drive does not pass these tests, it's removed from the rotation. The data on the hard drive is then overwritten to help ensure that no customer data remains on it. The data override is then verified with a complete disk read. This process helps ensure that there's no trace of customer data remaining on the hard drive. For hard drives that have reached the end of their life, Google has a destruction process that is designed to further ensure that none of the data on that drive can ever be accessed. The drives are destroyed in a multi-step process. One device that is used to destroy old hard drives is known as the crusher and is shown here. A steel piston is pushed through the center of the drive and the platters are deformed, making them unreadable. Another step in the process is the drive shredder, shown here. As you can see, no one will be likely to get any of Google's customers' data from these drives. After the crushing process, the remains are sent to recycling centers. Google maintains an extra backup of the data in the data center that is stored on these tapes, shown here. This provides a level of redundancy to help safeguard its customers' data. Google data centers are connected to the internet via high-speed fiber optic cable. In each data center, there are multiple redundant connections to protect against the possibility of a failure from a single connection. In addition to operating data centers designed for security and data protection, Google data centers are designed for sustainability and energy efficiency. This is central to Google's commitment to being a carbon-neutral company. In 2009, Google announced that its data centers currently met energy efficiency levels that the US Environmental Protection Agency projected only the most state-of-the-art data centers would possibly meet by the year 2011.
Let me just quickly reshare my screen.
Google builds and
is my screen visible, guys?
Yes.
Perfect. So this was a very short video, how Google is keeping their data, how Google data centers look like, how they protect the data. A very nice video. So let's move ahead. Before we move ahead, any doubts regarding client and server architecture? Anything you want me to explain once again? Because the next slide would be about your request response cycle. So anything you want me to explain, any topic you didn't understand so far? So shall we move ahead? Just give me a yes in the chat. Perfect. So the next part is the request response cycle. So we have been discussing this even during the client server architecture, that client is sending request, the server is fulfilling that request. So now we would be actually seeing what HTTP request looks like, how it gets traveled, and what are different parts of it. So before we proceed to those details, let's go through some very basic definitions, how it works. So a very simple diagram, I would say. The first is, suppose I, as user, sitting with my laptop, and I want to access some website. The first foremost thing is I would open my browser, right? Now I would enter the address. So let's suppose I've entered some address over here. So this is the address. Let it be any random address. So now this, once I click enter, my browser would send it to the web server. The web server would process it, and it would only process it if the web server is able to understand the request. And that only happens if the web server has the request in form of HTTP, as we saw earlier. For email servers, there is SMTP. For file transfers, there is file transfer protocols. So for web servers, for any web page requested, the request needs to be in form of HTTP. Suppose this request gets approved. Now server would collect all the data to create the web page that has been requested by us. So server would initiate a response, create the data. Suppose this was the data we requested. And now this data would come back to my screen. This is my screen. This is my client. I'm accessing the website, and this device is my client, and it shows on my screen, right? Now, this all is happening because of internet. In entire process, the World Wide Web is there. So let's see, this is assume this is World Wide Web. Whole internet is lying in between this. What we need to say is what the request was and what is response. This was our HTTP request. So if this was HTTP, then only it got approved. So this condition got fulfilled. And once the server receives HTTP request, it generates an HTTP response in return. The response is also HTTP. The main thing that we need to remember from here is any request, if it is HTTP in nature, that would be approved by web server. If it is not HTTP, if it was something else, server would have not generated this response. It would have rejected the request over here only. So remember, the right protocol needs to be followed. Okay. So now, before moving ahead, let's understand few web terminologies. Before understanding how web works, let's understand different terminologies. The first terminology that I want to cover up is HTTP, your hypertext transfer protocol. This is the most important technology, most important protocol that we need to take care. What is HTTP? We have understood that this is a client. It sends some request, it receives some response, and this is our database. Now this request, as of we know, is a URL. It's the website address that the client sends, and the response that we receive is the web page. So a normal definition, it is used by the browsers and it helps us load the web page. So let me clear it and show you a very beautiful example. Simple definition: protocol used by the browsers and helps to load a web page. A simple URL sent and web page received. This is used by the browsers. Supposedly this is a browser and this is our server. So HTTP is just a simple protocol used by browsers and helps load web pages. Now, why HTTP is being used? HTTP standardizes the process so that if there are different operating systems, suppose this is your Apple, this is your Windows, this is your Linux. So every time some user is requesting a web page, they do not receive something else. Each user will receive the same web page. If you open Amazon.com on any system, the web page would be same. Why? Because it is following standardized server rules, standardized protocol rules. So these are called standardized communication rules. Because our servers, our browsers and servers are communicating with each other. So HTTP standardizes the communication between various different devices with the server, because server would not change. It's company owned computers, and they would not change. They are at some unknown location and they're helping us out. But if request comes over here, if request comes from here or from here, if this is HTTP request, same web page would come. So it standardizes it. So that makes it easier for user. So if we just make it, it standardizes the request. Now, what happens inside the server is very interesting. Just see this. Browser sends the request, okay, and this is HTTP request, and this is sent to the web server after entering the URL. This is the browser. Suppose this is the browser, and here we enter URL, we press enter. Now, browser sends the request to the server. Next, what happens? The web servers in return send the data. This data is the response. It is the web page. And this data is the response. This was the second request sent. This was the first request sent. So browsers sending data through URL, and those need to follow HTTP protocols. Web servers in return send an HTTP response, and that response contains the web pages. The data is all about web page content. So if I write it, web page content. So this is the data we received over our screens. So browser in return sends an HTTP response. Second, the HTTP protocol runs over other protocols. Later in our sessions, we would be studying a protocol that is transfer control protocol. The first transfer control protocol is at lower layer. Above that, HTTP runs. So HTTP overpowers the TCP and then runs. So at first TCP needs to be set up and then HTTP runs. So HTTP runs over other protocols. It's just a simple fact that we need to remember. It is running under the hood. It's just good for our knowledge. Now, interesting fact, why HTTP protocol was named as HTTP. The only reason that HTTP was named, you can see from here, is hypertext. The hypertext shows that the data that is exchanged is in form of hypertext documents. What is a web page? Remember the definition, it's an HTML document. Hypertext markup language document, and this is being exchanged from server to the client. Server creates the web page and sends it to the client. Now, web page is an HTML document, and the protocol that follows in order to receive the web page, in order to send the request, was named after hypertext documents being sent. That is hypertext exchange protocol. Transfer is just an exchange of documents. So that's where the name comes from. So this is a very general definition of web terminologies. The next important part comes as what happens inside the server. Now we understood what is happening outside. What is this wait for data? What is this happening? That there is something that is happening inside it. Let's understand what's happening inside the server. Okay. Just a moment. Yeah. So let's understand what's happening inside the server. So let's assume there is a client and there is a server, a basic setup. Now our server is composed of different components. First component is the web server. We understood web server, that server which understands the HTTP protocol. Next is your database. It's the data source, data house, where all the data of the client is saved. And the third part is the connection between them. The database does not understand the language of client, but the web server does. So web server converts the client request into the required language and tells it to the browser. So let's understand the process. So I'll just remove this one. Yeah. So what's happening over here is, now let's go step by step. Client requests a web page, so it enters a URL, I would say, and goes for the search. Now this HTTP request is waiting in the line. The word waiting is very important. Why is it waiting? Why server is making it wait? Server is checking for the protocol. Is the request having HTTP? Yes. then it would allow. If the request does not have HTTP, then it would not allow. So in our case, the request is HTTP, it would allow. So now the first step begins inside the server. The HTTP request is transferred to this central area. This central area is connection between the web server and our database server. Whenever we are doing full stack with JavaScript, the internal link between the request coming from the web server to the database is the backend language. In our case, it's Node.js. Node.js converts the request into write format before delivering it to the database. So Node.js converts the request into the write format and delivers it to the database. So now what happens? The second step is, what's the database in our case? I'll quickly clear a few of these. So what's the database in our case? So as we would be catering MongoDB, so database in our case would be MongoDB. So this is how full stack is happening. Entire thing here, the front end part happened. Just see. Here, this part, the browser part, the client part, all the technologies were being written by the front-end developers, HTML, CSS, JavaScript, your frameworks like React. They created a web page, or they created a search engine wherein the user can type some request, press some button, and this request would be generated. Now comes the server part. On server part, first the web server checks the protocol, then it goes through the Node.js, it gets converted into the right format so that database can understand what the request is. And that database that we're using is MongoDB. Once the database understands the request, it provides the required elements needed for the request to be changed into a desired response. So it sends all the data required back to the Node.js. So now the database provided the elements, Node.js again converts it into format that web servers can understand. All this step happens, then web server has all the parts ready. It creates all the paths together and sends it back to the client. So this is how the structure happens within the server. We understood the part regarding client sending the request and receiving response. But this part, what is this part doing for us? This is what this is what this lecture was all about. It contains three parts. Very quickly, I'll tell you briefly. Web server, it checks if the response is HTTP or not. If it is HTTP, it provides the request to Node.js. Node.js converts it into write format so that our database could understand. We are using MongoDB. MongoDB provided all the user data or web page data back to Node.js. Node.js converts it into the right format so that web servers can create the attractive web page and deliver it to the web browser. So we can actually check what web response we are receiving. So let me show you right away how to check this. So let me open the Google folder for us. So I'll quickly close this one. So whenever you want to check what request was being sent, this was the request being sent, what response was being received, we can check it. Just right click over here and click on view page source. I'll just click on view page source. Allow me just a moment. Okay. Okay, where is that? Yeah. Can you see this one, the view page source? So when you click on this, this is the response that we received. This is all the HTML, JavaScript, and CSS written. You can check over here. This is all the script. The script tags tells us this is the JavaScript. This is not, we are not able to read it because this is in some encoded format. Our browser is able to debug it. Once the web server delivers this kind of response to the browser, and our browser has inbuilt capability to understand this JavaScript code. Lower, you can see the style tag. This is the CSS being written. You can see over here, the CSS. So this is the response we receive. So whenever we enter some web URL, we send it to the server, entire process happens, and the response the web server returns to us. this response, HTML, CSS, JavaScript, this is an encoded format. You can always check it by going to the view page source, and you can see entire code being written. So this might seem overwhelming. This is not written by one person. There are many developers in Amazon working on this particular website to create different elements. Some developers might be creating the header section. Some developers might be creating this image section. Some developers are creating the footer section, this one. Some are catering with the FAQs, hyperlinks. So different team of developers are working to make this website a wonderful experience. So this is a general example how response looks like when it comes out of the web server. So this is what happens inside the server. So let me see if we have time. I think we are out of time. The next topic that we would be discussing tomorrow is the status codes. What are HTTP status codes? It's very important. So do you have any questions regarding today's lecture? Let's take it for 2 to 3 minutes, the time that we have left. Any questions so far? Feel free to ask them in the chat if you want me to show any slide once again. If you want me to go through any topic very briefly, I can go that. Don't hesitate, just feel free to ask any question from previous week, from today's week, anything. Great, perfect. Talash, any questions or anything from your side for me?
No, I think it was amazing. It was amazing.
Thank you so
Yeah,
much, Talash.
Shakib was asked what was the subject of our class today.
So today, the main focus was what is a browser, what are features of browser, and then we covered different aspects as well, like what a client is, what a server is. We understood through the analogy of a restaurant, then components of browser, general client server architecture, and request response. The last part that we covered was the what happens inside the server, how response looks like. In the previous week, we covered what was network, what network components are, what a normal web page is, how internet travels across the world, what a website is, what is a flow of a web page, and everything. Next, tomorrow we would be covering what are HTTP status codes, what is your transfer control protocol, what is your IP addresses, what is domain name system, how everything is working under the hood together. So how your URL is being understood by the server. What are different components of URL? We would be studying that.
Thank you, Rahul. If there is no question, then we will wrap it up for the day.
Thank you so much, everyone. See you tomorrow, same time. And do go through the topics that we have studied so far. It would be easier for you to connect things that are coming ahead, because things are getting connected very fast together now. So do go through these topics, very small topic. Just spend 25-30 minutes every day. That's enough. That's enough, more than enough for these topics. Thank you, everyone. Have a nice day.